Hello everyone, welcome back to our pharmacy classroom. In this video, we are diving into a super important topic in pharmacokinetics, biopharmaceutics and pharmacokinetics. Method of residuals, also called as feathering methods. This method helps us to separate the distribution and elimination phases in a two-compartment model after an IV bolus dose. Sounds tricky, right? Don't worry, we'll break it down with a clear and easy approach. Introduction, we'll see first. The method of residual is a graphical technique. ये graphical technique है used in pharmacokinetics to analyze drug concentration time data. Especially useful for two compartment model after IV bolus administration. Also, it helps in separating the drugs distribution and elimination phases. Now question arises, why do we use this method? Okay, when a drug is injected intravenously, see IV bolus intravenously, we are injecting a drug. It does not get eliminated immediately. First, it distributes into tissues, that is distribution phase. Then it starts leaving the body, means elimination phase. But on a plasma concentration versus time graph, both these phases overlap. So we need a method to separate them, and that's where method of residual helps us. Did you understand this concept? Why we are using this? If yes, then we'll go ahead. Before moving on further, just recap the two compartment model. In two compartment model, we have central compartment as well as peripheral compartment. In central compartment consists of blood, well perfused organs such as heart, liver, kidney. In peripheral compartment, it is consist of less perfused tissues like fat, muscles. After IV bolus, the drug enters into the central compartment. Then it distributes into peripheral tissues. After distribution, elimination mainly occurs from the central compartment. So the plasma drug concentration versus time shows by exponential decline. Okay. So let's find out the plasma concentration equation. Here is the basic concept. In a two compartment model, the plasma concentration time profile is described as CPT equals to A power E minus alpha t plus B e power minus beta t, where you can see Ct is the plasma concentration at time t, AB intercepts of distribution and elimination phases, alpha and beta is the distribution rate constant and beta is the elimination rate constant. We want to find A, B and alpha and beta using this method. Let's see step by step methods. Okay, so step 1 will be the plotting the plasma concentration versus time on a semi-log graph. On x-axis you have to take time and on y-axis you have to take log plasma concentration. In step 2 you have to identify the elimination phase, okay, which is straight line portion, and then fit a straight line to this terminal part. By that you can calculate slope and intercept. Slope will be the minus beta divided by 2.303. Intercept will be the log b. Then third step will be the, you have to extrapolate the elimination line. You have to take it backward to earlier time points. This gives estimated concentration due to elimination only. Okay. Then you have to take step 4, which is nothing but you have to calculate residuals. Actual C minus extrapolated C. Like that you can calculate. Residual equals to C measured minus extrapolated C, that is B E power to the power minus beta T. Then you have to plot this residuals versus time on semi-log graph. This gives the distribution phase line. From this line you can calculate slope and intercept. That is, slope is minus alpha divided by 2.303 and intercept will be log A. Don't worry, I will show you how to do it, or I will show you the graph. After following all those steps, your graph would be look like this. Okay, your slope minus beta divided by 2.303 and the zero line slope will be the minus alpha divided by 2.303. Hope you are following this. So we are plotting the concentration versus time curve. We have two phases, elimination phase as well as distribution phase. Elimination phase will be this linear portion and distribution phase will be this curved portion. We extrapolate the elimination phase and subtract it to get the distribution phase. This is why it is also called as the feathering method, because of how the lines look on the graph. Now using this method we can calculate parameters. Our first parameter will be VD, apparent volume of distribution. We can calculate it as using this formula, dose divided by A plus B. And you have to note some points. A and B must be in the same units. It tells us how extensively the drug distributes into tissues. Then we have the plasma concentration. Actual drug levels in plasma over times we can calculate by this formula. A e to the power of minus alpha t plus B e to the power of minus beta t. Third one, we can calculate urine concentration. If renal clearance and urine data is given, how we can calculate? We have the formula, amount excreted in urine is equals to CuVu. So CuVu we have. Then we can use into this formula, renal clearance. CLR equals to CuVu divided by CPT. Then we have some terminologies like alpha equals to distribution rate constant, beta is equals to elimination rate constant, A, B are the intercepts of distribution and elimination phase, BD is the apparent volume of distribution, CL is clearance, CD is the plasma drug concentration at time T. Let's see the applications of these methods. Separating distribution versus elimination phases, we can use this method and separate them. And we can also use this method to find parameters, pharmacokinetic parameters in multi-compartment models. In some studies, urinary excretion data is also used. We calculate how much drug is eliminated in urine at different time points. But the method of residual is mainly based on plasma concentration data, not on urine. Still, knowing the total amount excreted helps in calculating renal clearance. Okay, common student dots. Some students will dot that. Common dots are why subtract residuals to isolate the distribution phase from total plasma concentration. And second question will be the do we always need this? No, only in two compartment models where phases are not clearly visible. How to identify when distribution ends? We can identify when CP versus time plot becomes a straight line, okay, on semi-log paper. Use method of residuals only when bi-exponential decline is visible. Also plot in concentration versus time to identify linear phases. Understand graphs, they reveal everything. Don't memorize equations blindly. Understand what each term means. Pharmacokinetics is all about understanding what the body does to the drug. That's it for today, friends. We have learned how to break down the complex two-compartment model into easy phases using the method of residual. If you found this helpful, hit the like button and subscribe for more pharmacy content. And as always, keep learning, keep growing. Thank you.